Hello again, YouTube. I left this the last time we just did we created this a new version of a project basically, so we could do source control, version control under GitHub. So if I just look at the list of tags, tag -L, I've got the tag for the episodes that coding was done in. Now the last episode was episode 10, but that was just setting up this Git repo, so there's no tag for that. There's no code. So if we list the branches, we're on master. Now I want to continue from episode 9 where we talked about platform independence, and to do that the normal way we'd work is we would create a new branch. So if I create a branch for episode 11 and then check that out, so I'm switched to that branch. So now if I do a git status, I can see I'm on that branch. So all work that I do will now be attached to that branch, and I can either merge that back or just dump it if I'm not happy with it. So let's make a start. I was talking about platform independence, and the reason this came up was because I was trying to make morse.c, this file, I was trying to make it platform independent, and we got to the end of it where we were in episode 9, and basically down the bottom we got to a point where we wanted to turn the channel on. We're transmitting either a dot or a dash at this point in the code, so we have to turn on the channel and then start a timer. So at the minute it's platform independent, and you can see this if I go into the source directory and if I compile morse.c, was the example I used, that's compiling down to morse.o. If I do a file morse.o, you can see that it's compiled into x86 64-bit. So this is compiled for the 64-bit x86 architecture, so it's platform independent. We can also compile it in here for our PIC33. Now C is, despite what people might think, C is platform independent. Once you've got a compiler, it's platform independent. Now, people used to bang on in the day about Java being platform independent, but to be honest, Java was, whilst it could potentially be platform independent, it was really limited to an x86 architecture. So it was more operating system independent. You could run an application on Windows or Linux or on a Mac, but if you tried to run that on a Spark processor, there was no readily available Java runtime environment for a Spark or for whatever other processors you can think of. So Java wasn't really platform independent. C is platform independent. I can compile this for anything if there's a compiler for that processor, and there's very few processors even down to microcontroller levels that don't now have a compiler. So I want to turn on the LED. In our case, we're trying to turn on a LED, so we did this by setting lat D1, just set it to 1. That's us turning on a LED. Now this XC16 compiler is happy with it because the IDE, this NetBeans clone, has included the header file for that definition. So it's included the DSPIC33 header file, and I can jump to the definition of that. It's a large file, but yes, we'll load it, and that's our definition for that definition. But that means something to this compiler, the XC16 compiler, because it has these header files and everything set up. If I now try and compile that again, sorry, if I save the file, that header file doesn't mean anything on an x86 platform. And if I delete that line, save it again, it's now saying that lat D bits, that doesn't mean anything on in the x86 architecture. So there, that code is now platform dependent. So how do we get around that? I suppose in any kind of programming languages there's a number of ways you can do things, but I'd usually, well, I suppose there's two ways of doing this. The first one, I suppose, we want this line. When you're dealing with code, you try and separate files, like in my case morse.c. I want morse.c to be platform independent. I want to compile that for anything, because it isn't really specific to any. Morse is not specific to any platform. You can transmit Morse on pretty much anything. My application code, this main.c, it is platform dependent. So I'm going to try and put all the platform dependent code into this file. Now we could make main.c platform independent. We may do that in the future, but for the minute we'll just localize platform dependent code in here. And to do this, we're going to just create a function, and it's going to be void, return a void, and it's going to do, we'll just call it Morse on, and it accepts no parameters, and all it does is execute that line of code. Likewise, we can have a platform dependent function called Morse off, which turns that channel off. Now we haven't messed with morse.c at all. Those two functions are very much platform dependent. They're calling special function registers in the DSPIC33. So now there's two ways of doing this. The first way, and not my favorite way, would be if I took that function that's hard coded with a name and put a declaration to that in the top of my file. Say that it's external. So we're telling the compiler there's a function, Morse on, that accepts no parameters and returns no return value, and it's out there somewhere, and we can call that. Now GCC is going to be happy with that because that's fine. It's not trying to link, because I'm using the -c option to GCC, it's not trying to link this into an executable. It's just compiling this to see is it valid C, and it's valid C. This will compile as well because it's happy, and it will actually link to the whole executable, the whole program for flash, the binary file that we can program into the flash of the device. But I'm not a huge fan of that method because you're hard coding a function name, and there are advantages to it, but I would much prefer to use a pointer to a function. So at the minute, if I say, now C declarations can get hugely complicated. This line says channel on is a function, it accepts no parameters and it returns nothing. If I put an asterisk in front of that, it's now a function that accepts no parameters and it returns a pointer to a void. So it actually returns an address in memory. If I put a parenthesis around the function name, now we have a pointer to a function that accepts no parameters and returns nothing. So this is now an address, and we can set that equal to null. If I could spell and type. So we've got a pointer to a function that returns nothing, and we're initializing it to null. So we can dereference that pointer. We can actually call that function, by saying channel on, and the compiler is completely happy with that. Now the compiler hasn't spotted a huge bug in the code because we're calling a function which we've initialized to be null, and that will actually, in most architectures, the address 0 is in a lot of architectures. Well, I don't know about most, but most of the ones I've encountered, the address 0 is the jumping point for the code, so that will actually reset the processor as if it's been powered up. So when the processor powers up, it starts executing from address 0. So if we execute this function, dereference that pointer to a function, we're resetting the processor. We don't want to do that. We want to check that this is actually pointing to a valid. If that is pointing to something, then execute the function. Otherwise, don't. Now this, as it stands, it's got a pointer to a function and it's dereferencing that pointer to the function and calling it. So GCC is still happy. It's still got a runtime error in that it's going to get to a null address and try and execute. Linux, the operating system, will try and protect against that because it's probably jumping to something outside of its memory allocation, so the memory management will stop it. But for the minute, it's going to compile. So how do we get these, set up these pointers? To do that, I'm going to change the initialization function. The initialization function for this module accepts no parameters at the minute, but I'm going to say I want to be passed in the address of a function. And one function is for on, and it's going to accept no parameters and return nothing. And the other function pointer, so these are two addresses, is function off, and it accepts nothing. And then inside these, I'm just going to say those two variables, which I should say are static to this file, they're just local variables in this file. So I'm going to say the channel on function pointer, set that equal to the parameter we've been passed for an on function, and channel off is set to off, the off function. And that's us. We've changed this prototype, so we should actually change the API function, which is defined in morse.h. So our morse.h, which defines our API, we're going to say there's an external morse in it, and get rid of this. So now we have a morse.c, which when initialized is passed two functions, and it will execute those functions when it wants to turn channel on and off. Now, because we've changed that header file, the API, we've now broken our application code. So if we try and build this, it's probably going to compile, or should compile morse.c, but main.c, it's actually calling an old version of the API. Our new version of the API is broken main.c, the application code. Now it still compiles, morse.c still compiles under GCC. So what we want to do now is basically in this call morse on, not call morse on, sorry, pass call morse in it, and pass in the address of the two functions that we want used. So we're telling the morse module, initialize the morse module, and these are the two functions we want called. Now these two functions can do whatever they want. The module morse.c, the functions in there don't care. That's up to us. So now we have two we've still got this platform independent code. The one thing I will say now is that the next thing we want to do, as this comment suggests, is we're transmitting either a dot or a dash, and it's stored in this little byte buffer. It's a buffer, but it's just a byte, and the zeros and ones in this buffer byte dictate whether we're transmitting a dot or a dash. In either case, we want to do a bitwise AND with the mask. And if it's a 1, we want we're transmitting a dash. we want to start the timer. The only other option is that we're transmitting a dot, and again start the timer accordingly. So now we have to get into starting of timers. So that's very much platform dependent, and we have to tackle that. So I'm going to leave it there, tackle timers the next day. Now, one thing is I noticed when I was going over code, it's one of the advantages of going over code reviews, and even if you read over your code the next day, I meant to put a comment in here. So if the transmitter side, we wanted to loop over all the characters. So that's what the if statement is doing, working out is the transmitter idle. And then we want to transmit the first valid character. So the while loop was to go through get rid of all so ignore all the characters that are invalid. Now there's a number of bugs in this. First of all, I copied the if statement from down here. And it's completely wrong in the context of where I've put it, because the actual logic says if the character we're looking at is less than A and greater than Z. Well, it can't be both. That should have been an OR. So that's the first bug. Second bug, which is possibly more serious, or is maybe harder to find, is if somebody passes in the string, I'll put it in double quotes here, if somebody passes in space, asterisk, $, $4W. That's my string in double quotes. The way this loop is going to work is that when the pointer comes in, it's initialized to point at the space character. So the while loop is going to say if it's less than A or greater than Z, it's invalid. And this is invalid. The space is invalid. It's not less than A, or it is less than A or greater than Z. So it's going to increment the pointer. So now it points at the asterisk. Again, that's invalid. So it's going to move on to the next character, which is $. Again, it's invalid. Increment the pointer. We're pointing at the 4 character. Again, it's invalid. So we eventually end up with a W. And this OR is false, because the W is between A and Z, and it's going to drop out. And we're going to call this txchar function with the character that we're pointing at, which is the W. The problem is if somebody passes in no valid character at all. What this loop is going to do is what it was doing, which is going test the space. It's invalid, move on. Test the asterisk, invalid, move on. Test the $, invalid, move on. 4 is invalid, move on. Ampersand is invalid, move on. We get to the null termination. The null termination is a 0 at the end of the string, and this while loop is going to say, well, it is less than A, so move on. So we've gone past the end of the buffer. We've actually overflowed out of the buffer that we've passed in, this message buffer, which is probably on the stack, so we're going all off the end of the buffer into the stack somewhere. So basically we want to make sure that that pointer is pointing at something. So while that pointer is pointing at something and the character is invalid, keep incrementing the pointer. So now we've got two reasons for dropping out of this while loop. Either the character is now valid, we're pointing at a valid character, or we're pointing at the end of the string, which is the null termination. So we don't want to call, we want to test this and say, well, if we're still pointing at a character, we're not pointing at null, then we want to transmit the character we're pointing at. Otherwise, don't try and transmit it. And we get to the next block of code which says while the pointer is pointing at a character, it's already pointing at the end of the string, so we just pop out. We're going to come out. So that's a number of bugs that were in that was in just in that small block of code. And there could be more. I'll read over it and go, oh yeah, what was I thinking? So that's where I'm going to leave it. Like I say, I'm going to come back to timers, but for the minute I'm going to leave that, and that's the function pointers that might take a little bit of getting used to, but I think it's just there's a function at a certain page or address in memory, just go and execute it there, come back. It's small potatoes really when you get the hang of it. And yeah, I'll put some comments in this and push it up to the GitHub repository. So that's the episode. Thanks a million for watching, and next time I'll get into timers.